Hi everyone, this is Jay Beeks, your instructor for Renewable and Alternative Energy, EPM 4230. As you know by now, our main reading resource for this course is Energy for Sustainability, Foundations for Technology, Planning and Policy by Randolph and Masters, and I have it here in front of me. It looks like it's an excellent book so far. This is my first time teaching this course at this school. This is about my third course at University College so far. A little bit about my educational background. I received my bachelor's degree in mechanical engineering from the University of Arizona, and spent quite a few years, 2.5 decades, working in mechanical engineering, as starting out as an engineer and then a lead engineer and then an engineering manager. Worked primarily for utilities, Southern California Edison, and Portland General Electric up here in Portland where I live. After that, I actually got laid off at the Trojan nuclear plant here in Oregon, and I decided to go back to school, so I picked up an MS in environmental science, and then following that I picked up an MS in civil engineering. Spent another, say a dozen years working in civil engineering and environmental engineering with consulting firms, and I also worked for the state of Oregon. And then I finally went back and picked up my PhD, which is in transformative studies, but the focus is on sustainability and sustainable leadership. So I spent about half my life working and about half my life going to school, I'd say. My work background, as I mentioned briefly, I started out working as a mechanical engineer for Southern California Edison. I was working in coal generating facilities. Big ones was at the Mojave Generating Station, which is a 1,600 megawatt plant. I was a lead performance and lead reliability engineer there. I then worked at with the same utility, Southern California Edison, at San Onofre, the nuclear plant, which is now shut down. Worked there for about 5 years. And then I wanted to move up to Oregon, so I transferred up here to Oregon. I started working at the Trojan nuclear plant, and unfortunately, about a year after I got here, they shut that plant down. So that was a bit of a shock after having moved my family up here, and 2 kids, my wife, and a cat and a dog, and all of a sudden we're here with a house and no job. So that's one of the reasons why I spent some time going back to school and getting educated, or getting further education. In addition to that, I was an engineering manager with Oregon State Parks for about 10 years. And I should mention, when I was working with Southern California Edison, I worked on Solar One, which was one of the first prototype solar plants that was built. It was really, I guess you'd call it a thermal solar out near Barstow. And it was a little tiny 10 megawatt plant, but it was a boiler up on top of a tower. And we had all these mirrors focused on it that were articulating, and they changed their angle during the day. It ended up being not a very successful project. But the idea was that inside this boiler, which was more or less, it was just a big container, it was full of thermanol, and the thermanol would heat up, reach a boiling point. That would go down through a steam generator, and the steam generator would exchange energy with a water system, because it was a 2-cycle steam generator, primary and secondary. So the primary was the thermal going through it, the secondary was the steam. The steam would flash off, and that would drive a steam turbine. And again, it was only about a 10 megawatt plant, but it was a big expenditure, and it just didn't work out very well. But the reason that, one of the reasons was because the mirrors got the boiler so hot that we were about to melt the boiler. So we had to change the focal point of the mirrors quite a bit off of the boiler, so that we didn't essentially disintegrate it in place. But I think one of the reasons Southern California Edison liked that idea was because it was a centralized way of producing electricity. And it's not something that somebody can just do in their backyard. It's quite different than PV panels, for example. And so being a large utility with millions of customers, it was in our interest to have everything decentralized so that the customer would have to then pay for that power to be shipped to them without having the capability of generating it themselves. And anyway, it wasn't a very successful project, as I mentioned, but the one advantage of that type of a solar design is that you can generate power after the sun sets. So we had the capability of generating power up to 4 to even 6 hours after the sunset, and that is one advantage over PV. But I can tell you that having worked in several different types of electrical generating facilities, coal, oil, gas, nuclear, solar, wind, I would not recommend anybody work in a place like that. And I had near-death experiences at coal and oil plants. Came very close to getting blown up at Mojave, which is in the tip of Nevada, back in 1986, when we had a coal reheat pipe rupture that killed about 12 people and missed me by about 60 seconds because I happened to be doing a performance test at the time. But we had a coal reheat pipe that just opened up like a flat plate, like a pancake, and it was a 30-inch pipe, and it was 600 pounds pressure, about 800 degrees Fahrenheit, and it knocked down the control room wall and essentially turned the control room into a pressure cooker for everybody that was in there. And again, it just missed me by 60 seconds because I had been in that control room all day, and I just happened to walk out to go check on a valve that somebody wanted to know whether it was open or closed. So anyway, if I was to work at any kind of a generating facility, it would not be a conventional steam generation plant or a nuclear plant. If I had my druthers and I was starting all over again, I'd be working in PV plants and wind farms. They're much safer, and they're decentralized for the most part. A lot of them are owned by utilities, so they're centralized in that regard. But the advantage of PV is that it can be put on your roof, so you can have rooftop solar that is decentralized, and the same goes for wind turbines. A lot of people can actually have a wind turbine in their backyard, and they can be generating electricity that way and supplying to the grid. So as we get into this course a little further, we'll see some of the advantages of decentralized as opposed to centralized power. So a little bit about my teaching experience. It's been going on now for about 6 years. I'm only teaching graduate courses in sustainability subjects. This includes a global energy course at Franklin Pierce University. At ASU, I've been teaching for several years in the Masters in Sustainable Leadership program. I teach the 3 core leadership courses there, as well as the capstone courses. I did a lot of teaching for the Green MBA program at Marylhurst University. Unfortunately, Marylhurst University is no longer with us. They shut down just because of lack of enrollment. I also teach at University of St. Francis for the Green MBA program. Then here at Denver University with this course and others, I'm teaching sustainable transportation. I've already taught impacts of recreational use. That's because I worked as an engineering manager with the state of Oregon Parks and Recreation for about 10 years. And I've just redeveloped a course that some of you may have taken or you're going to take. It's Integrated Environmental Systems. That's a pretty interesting course. I've revamped it completely. The main textbook for that is this book, Variety of Integral Ecologies. And a couple other books, Drawdown by Paul Hawken. I'm sure a lot of you are aware of that book, Drawdown. And I hope to reference that book in this course, actually, because it has some really interesting things to say about renewable energy and the impact renewable energy can have on drawing down CO2 out of our atmosphere. And then also in that course, we're using this book, New Reality, which was written by Jonas Salk and Jonathan Salk. Some of you remember Jonas Salk. He was a medical doctor that came up with a cure for the polio vaccine. But that book was only published in 2018. Jonas Salk started it in 1986, but I use that a lot in that course as well because it talks about our overpopulation problem and how we have to rethink what we're going to be doing going forward, particularly in this century. It's really important that in this century, in the next 20 to 30 years, that we rethink the way we're doing things so that when we reach the year 2100, we won't have depleted our resources to the point that our population curve, which is right now exponentially going up, so that it won't start going exponentially down, in other words, forming a bell-shaped curve because of lack of resources. But if we're smart about how we do things, if we conserve our resources and we do things such as wide-scale implementation of renewable energy, we can actually go into an S-curve, according to Salk. It's a sigmoid curve. We're still in the vertical portion of the curve, just about with population growth versus time. But if we're smart about how we do things, we can level off at 2100 at roughly 11 billion people, which is, I know that's a shock to a lot of you, but the handwriting's pretty much on the wall. We're going to have 9 billion at least by 2050 and 11 billion at least by the year 2100. And the scary part about that too is those 11 billion are all going to be, mostly 80% of them will be at the age where they can reproduce. A lot of them are going to be less than 40 years old. And that's a scary prospect if you think that we don't have some type of way of controlling our population growth by the time we get to the year 2100. Anyway, this course is not about that, but I think that's going to be another interesting course if you haven't taken it already. So wrapping up, I do hope that you all enjoy this course, and I look forward to seeing you online. It looks like that's going to be tomorrow. And welcome to the course.